This video will cover pattern matching and replacement in text data using the string-R library. The R code and data used in this video are available in the Learning Management System. This video will use the hourly weather data 2017.rds data file. You should download it now if you'd like to follow along. By the end of this video, you will understand what string-R functions are available for detecting and replacing patterns of text in your text data. The string-R library provides robust functions for pattern matching and replacement. These functions all use a language called regular expressions to define these patterns. This is a robust language for expressing text and patterns. It's very useful, but it's complicated, it takes time to master, and I'm not going to cover it in this video. But as an example, the piece of text that I have here would match any valid UMD undergraduate course number. Again, this is pretty complicated, but on the bright side, the text AREC 380 as a pattern would match AREC 380 in a string. So if you're looking for specific pieces of text, these functions are very easy to use. The first is the pattern matching function. This is string detect. It takes two arguments, a string and a pattern that you'd like to search for. This function will return true if it finds the pattern anywhere inside the string and false otherwise. String detect is very useful in filter commands, since you can use it to filter your data based on the content of your text variables. There's also the string count function. Again, this takes a string as an argument and a pattern that you would like to look for as the second argument, and it's going to count the number of times the pattern occurs inside the string. The way that it looks for this pattern is greedy. What it's going to do is start at the left-hand side and read to the right. After finding a match, it's going to discard everything up to that point and then keep looking to the right for additional matches. The string replace function takes three arguments: the string you would like to process, the pattern you would like to look for, and the replacement you would like to use to replace it. It's going to replace the first occurrence of pattern inside string with the text you specify as the replace argument. As a pro tip, you can make replace an empty string to get rid of a piece of text that matches the pattern. String replace will only ever make one replacement per piece of text. String replace all, however, replaces all occurrences of pattern inside string with the text specified in replace. Just like string count, it performs greedy matching. It's going to start at the left. When it detects a pattern, it's going to replace it, then keep looking to the right of that pattern for additional matches. It's also only going to make one pass through your text. So if your substitution somehow introduces new versions of the pattern, they won't be replaced. We can get some practice using these functions in R. Remember that the string-R library is part of the tidyverse, so it's loaded by my setup code that loads the tidyverse. Let's take a look at some examples of these pattern matching and replacement functions. I'll define a couple of variables. Example.1 will hold the text hello, and example.2 will hold the text hello world or good night moon. In the first example, I'm going to use the string count function to look for the text OR in each of these strings. As you can see, example 1 contains no instances of the text OR, and so I get a 0 for string count. Hello world or good night moon contains two occurrences of the letters O and R, and so string count gives me a result of 2. Remember that string count performs greedy matching. It's going to start at the left-hand side, look for a match. When it finds it, it discards everything up until that point, and then continues looking to the right for additional matches. In this example, I have the letter A 5 times, and I search for the pattern of AA. String count looks at this string, finds a match in the first two characters, that counts as 1. It then starts looking again at the third character, finds another 2 letter A's, that makes a count of 2. All that's remaining after that is just 1A. That doesn't match the pattern of 2 A's, and so there are no additional matches. The next function was string replace. Remember, this replaces patterns in your text with additional text that you specify. Here I've taken that example 2 text. I specify the pattern that I would look for as the letters O and R, and I replace them with an exclamation point, capital O, capital R, and another exclamation point. You can see in my resulting string, the OR in world has been replaced. String replace only replaces the first occurrence it finds, so the OR between world and good night is left intact. I can replace all of them with the string replace all function, as you can see here. In this case, both the OR in world and the OR between world and good night have been replaced. Remember that string replace all only makes one pass looking for patterns. In this example here, I have kind of a complicated piece of text. I'm looking for the text hello, and I want to replace it with the empty string, double quotes, which will remove hello from my text. You can see as it looks through, it matches the characters H-E-L-L-O in the center and removes them. The resulting text is still H-E-L-L-O, but because it only makes one pass through, it doesn't replace that text. As an example, so you're aware, the patterns are actually regular expressions, which is a robust and useful syntax for pattern matching in text. Here in this example, I've specified a regular expression that will match either the letters OO or the letters OR, and have specified they should be replaced with two X's. And you can see the OR in world, the OR between world and good night, but also the two O's in good night and the two O's in moon have been replaced with double X's.